series where we are doing one question of data structure algorithm each day. So today we have minimum stack problem. So it comes into the stack category. The problem says design a stack that supports push, pop, top, retrieving a minimum element in a constant time. Okay, if you will focus here, retrieving the minimum element in constant time. The question is specifically asking to retrieve the minimum element in constant time. So if we want a minimum element in a constant time using stack, definitely we have to store somewhere that minimum element at each point. What I'm trying to say, for example, this is your stack. So in your stack -2, 0, -3, the minimum element -2 is -2, at minimum element at 0 state is -2, and at minimum element at -3 state is also -3. So at each stage we have to keep the minimum element. So that's how we will be able to solve this question. We will need an auxiliary stack to store the minimum value at each state. So the top always represent the current minimum and popping restores the previous minimum. So what I'm trying to say, I will try to explain you. Okay, let's say this is our input 2 3 4 1 4 1 5 6 7. Okay, so this is my stack. I put 2. At that time I put value in minimum stack as well, because we are using auxiliary space as we want constant time. 2 at this, when we put 3, we will check if 2 is greater than 3. No, it is not, so the minimum will be 2 only. Then we will check 4, that 4 is greater than 2. No, it is not. 4 is greater than 2, so 2. Then 1 is greater than 2. No, it is not, so 1, we will put 1 in minimum stack. So at this stage we will say, see, at one state we got new minimum, and if I am popping 1, if I will pop out 1, so still my minimum will be still my minimum stack will give me the correct result, because I will pop from minimum stack as well. So let's say 4, and here let's say 1. Now I can add 4. Now again I have to add 1 here, as we are 4 is bigger than 1. Then 5 6 7, so all in all places we will keep 1. So the minimum stack is doing, it is keeping the history of the minimum element for our stack, for our original stack. So let's try to do this question. Stack int st, and one more stack int min st. Okay, so if push, we will push in min stack only if our element is less than it. We will do it. If it is less than 0, then obviously we'll push it. And minst dot size equals minst dot push well. Okay, if it is not size 0, then what we will do, minst dot push minimum of well, comma, whatever the minimum we have so far, not top. Okay, and obviously in our stack also I have to push st dot push well. If we want to pop, we will simply pop up on both, st dot pop min st dot pop, and for top return st dot top, and for min return st dot min st dot top. So let's try. Minimum stack will be minimum of all the elements in the main stack. That is the main invariant here. Thank you.